Learning by activity is a very effective methodology for teaching and learning mathematics. This is because experience gained by the child remains in his mind permanently and meticulously. I therefore have chosen this particular idea or this particular concept, and therefore the name of the teaching aid is Learn While You Play. Now here I have used the topic, I have taken the topic circle. Now circle being an abstract concept, I have used some concrete materials as models so that the child understands them very easily. Thus, the working model of this, let us see the model. Now how does it work? Here is the model which tells you the concepts of circle, wherein the circle is nothing but a set of points, right, at a fixed distance from a fixed point, the fixed point being the center, and the fixed distance OP being the radius of the circle. Similarly, OR is the radius of the circle. Now OP and OR are in the same line, therefore this forms a double of the radius, and therefore it is called as the diameter of the circle. This is the tangent, the line touching the circle, tangent of the line to the circle. The line intersecting the circle in 2 points is a secant, and this is the chord. Thus, the basics of the circle can be seen in this particular model. Now here, we can observe points A, B, C, D, they are lying in the interior of the circle, thus representing interior of the circle. Here the points lie on the circle X, Y, Z, W, and here you have PQ, RS points lying in the exterior of the circle. Now here are the types of circles. To understand the types of circles, observe the red circle. Let us take this blue circle and place it over the red. Does it coincide? Yes. That means these two circles, they have the same common center and a congruent, radii are congruent, and therefore they are called as congruent circles, and they are the circles in the same plane. Now these circles are also in the same plane, but they are touching each other at point P, that is a point of contact, and thus they are called touching circles or tangent circles. And they are also touching externally, so they are also called externally touching circles. If you see, the green circle is touching the red circle at point Q. Thus, these green and red circles are also touching circles, but they are internally touching circles. Now, if I place this black circle, right, green circle inside red and the black one also inside the green, what I observe, they have a common center O. Thus, the circles in the same plane having the common center O and different radii, they are said to be concentric circles. So, these are the different types of circles we have observed. Now, here you can see point O is the center of the circle, and you can see the point Q and R are joined by a segment, that is QR is the chord of the circle. You can also see OP is perpendicular to this chord. Thus, if you just measure P to Q, the length PQ and the length PR, what do you observe? Length PR and length PQ, they are of the same length. That shows that perpendicular from the center of the circle to the chord bisects the chord. Now here O is the center of the circle, and here AB is the chord as well as CD is the chord. If I remove this chord CD and place it over chord AB, what I observe, that the chord CD and AB, right, they are coinciding over here. That means AB and CD chords are congruent chords, they are of the same length. Now if I observe point O and that is the OQ is the perpendicular to the chord CD. You can see OQ is a perpendicular to the chord CD. The same way, OP is a perpendicular to the chord AB. If you see this particular perpendicular OP and this perpendicular OQ, they are of the same length. So again, what does that mean? That the congruent chords of a circle, they are at equidistant from the center of the circle. Now here, quadrilateral A, B, C, D, the vertices of this quadrilateral, they lie on the circle. Therefore, this quadrilateral ABCD is a cyclic quadrilateral. In this cyclic quadrilateral, angle ADC and angle ABC, they are opposite angles. Now this angle, opposite angles, they are supplementary. If you observe, this measure is 180 degree and this particular angles, therefore they are also 180 degree. That means opposite angles of a cyclic quadrilateral, they are supplementary. Now this angle ADC and angle CBE, if you observe, this angle CB is in the exterior of the cyclic quadrilateral. That means this exterior angle of a cyclic quadrilateral, CBE, is congruent to this remote interior angle of the cyclic quadrilateral, that is angle ADC. Thus, it proves a corollary of cyclic quadrilateral theorem, that is remote interior angle of the cyclic quadrilateral and exterior angle of the cyclic quadrilateral are congruent. Here, angle BAC has its vertex on the circle. Therefore, this angle BAC is called inscribed angle. Angle BOC, if you see, its vertex lies on the center of the circle or at the center of the circle. Therefore, this angle BOC is called as a central angle. Now, if you measure the central angle, let us measure the central angle. You see, this is the measure of the central angle and this will be the half of this measure. If this half of the measure, I place it at this particular angle, at the vertex of this angle, you see it is exactly half of this particular central angle. Now this central angle is congruent to this intercepted arc BXC, and therefore you can say that the inscribed angle theorem states that the inscribed angle is half of the measure of the intercepted arc. Now here, angle ADC is also inscribed. Angle AEC is also inscribed angle. That means these three are the inscribed angles because their vertices, the vertex of each of these angles lies on the circle. Therefore, these are called as inscribed angles. We have just now seen. So let us measure these inscribed angles now. This measure fits exactly over here. That means this is congruent to this measure. This is congruent to this measure. That means these inscribed angles which are inscribed in the same arc. These are the inscribed angles inscribed in the same arc. They are congruent. This is a corollary of inscribed angle theorem can be proved. Here the tangent secant theorem. What is this tangent secant theorem? The angle which is made by the tangent AB and the secant CD from the point of contact of the tangent, right? The angle formed by these tangent and this secant is half of this measure. That means this is half of this measure, and this measure is nothing but the central angle, and this central angle is congruent to this particular arc. That means this angle is half of the intercepted arc. This tangent secant theorem can be proved. Now this tangent secant theorem also you can observe that the center of the circle lies on the arm of the angle. So in this case also this particular the thing which we have observed is this angle is half of the intercepted arc. The same thing we can observe also in this case, because again we have the angle between the tangent and the secant, but here the center of the circle lies in the exterior of the angle. But here again you can see the measure of this angle is half. You can see this is the half of this measure, this central angle, and this half is exactly equal to this. That means this particular angle which is congruent to the intercepted arc CED, right? Therefore, this particular measure is half of this intercepted arc. That means angle DCB is half of the arc CED. Here again, the same angle, that is the tangent secant angle, the angle made by the tangent and the secant, right? Its measure is half of the intercepted arc. This is the central angle measure, and this central angle corresponds to the intercepted arc. Right? Now this intercepted arc, right, is this measure, the central angle measure, and this is the half of the central angle, that means it is half of the intercepted arc as well. Now this it fits exactly in this particular angle, half of this. That means this angle is half of the intercepted arc, is again proved in another case when the center of the circle lies in the interior of the angle. So in this manner, the child will understand the theorem with the help of these particular different models and find it very easy to remember and understand it, and also learn its theory with the help of, right, these charts, and thus will able to prepare for his exam and write it, the theorem as well, by studying it thoroughly. Thank you so much.